In this video, we'll state a few theorems about the determinants. We'll only prove one of them, however. This I have already stated, but the determinant is well defined. And what we mean by that is that when we define the determinant, you are asked to make a choice. You select a row, you select a column, but that choice doesn't actually matter. It doesn't matter which row or column you use to define the determinant. You'll get the same number in either event. Theorem. I've mentioned that there are ways of approximating the determinant that computer algebra systems use instead of the definition we stated. Those methods are based on this theorem. If A and B are n by n matrices, the determinant of a product is the product of the determinants. And the way these determinant finding methods work is to try to take the matrix you care about and write it as the product of simpler matrices whose determinants you can find. What would a simpler matrix look like? Definition: a matrix is upper triangular if all the entries below the main diagonal are 0. Theorem. The determinant of an upper triangular matrix is the product of the diagonal entries. This is the theorem I said I'd prove, actually, as we so often do in this class. We'll look at a special case and observe that the method we use in this case works in other cases. And the special case is that we've got a specific dimension. Let's work with 4x4 matrices, and let's show that the determinant of this matrix is A times E times H times J. Our sign chart is going to be, well, the only part of the sign chart that's going to matter is this plus up here, because we're going to select that first column, and that will give us A times the determinant of this, minus 0 times something plus 0 times something minus 0 times something. So, of course, none of those terms matter. And now we need to take the determinant of this 3x3 matrix. All right, new page. We're looking for the determinant of this upper triangular matrix. We found that it was A times the determinant of this. When we take the determinant of this, we'll work down the first column. E times the determinant of this. And then minus 0 times something plus 0 times something. That doesn't matter. So we've got A times E times the determinant of this thing. And to find this determinant, we multiply the diagonal elements, and we multiply the diagonal, anti-diagonal elements, and we subtract them, and of course this is 0. So we're left with A times E times H times J. The product of the diagonal elements. And if you have a diagonal matrix of any size, the same strategy we used here. Select the first column, select the first column, select the first column. We just keep selecting the first column, and every time we do, we get one of these diagonal entries thrown into the product.